Welcome to Solar Age, the podcast that shines a light on the path to a brighter, more sustainable future. Join us as we explore the transformative power of technology in creating a Solarpunk world.
All right, so today we're diving into tech that almost sounds like science fiction, to me at least. Batteries that are also the structure of a device. Imagine like the frame of your phone being the battery itself, or the body of an electric car, providing the juice. So that's the wild world of structural batteries. And for you, as a Solar Age podcast fan, this has huge implications for the future of renewable energy. Our source today is a recent Yahoo Finance article highlighting a breakthrough from Chalmers University of Technology in Sweden. So let's unpack this and see just how big of a deal this could be.
Yeah, I think what's so exciting here is the potential for a complete paradigm shift. We're not just talking about slightly better batteries, but a whole new way of thinking about how we design and power our devices.
Yeah, the article mentions laptops that are half their current weight, phones as thin as credit cards. I mean, come on, that's insane.
It really does sound like something from a sci-fi movie. The key here is carbon fiber. It's already, a superstar material known for its strength and lightness. But the researchers at Chalmers have figured out how to make it act as both the electrode and the structural component of a battery.
Wait, so the carbon fiber itself is storing and releasing energy. That's pretty mind-blowing. Can you remind me again how a normal battery works so I can wrap my head around this?
Sure. So in a traditional battery, you have two electrodes with an electrolyte solution in between. Think of it like two sponges with a liquid that allows ions to flow between them. When you charge the battery, ions move from one electrode to the other, storing energy. And then when you discharge the battery, the ions flow back, releasing that stored energy as electricity.
Okay, that makes sense. So with this new technology, the carbon fiber is acting like one of those sponges, right?
Exactly. And the really clever part is they've managed to do this while still retaining the carbon fiber's structural properties. It's strong enough to be used in load-bearing applications while simultaneously storing and releasing energy.
Okay, I'm starting to see why this is such a big deal, especially for applications like electric cars and lightweight electronics. But the article did mention a challenge with energy density. It said these structural batteries don't store as much energy per unit of weight as conventional batteries. So does that mean it's a trade-off? Like, are we sacrificing power for lighter weight?
That's a great question. And it gets to the heart of why this technology is so potentially revolutionary. Yes, the energy density of a structural battery is currently lower than a conventional lithium-ion battery. However, the weight savings from integrating the battery into the structure more than compensate for that difference.
This is like, you don't need as much battery power in the first place because the overall structure is so much lighter.
Yeah, that's exactly it. Think about it this way. With a traditional electric car, you have a heavy battery pack taking up space and adding weight. With a structural battery, the car's chassis itself becomes the battery. This reduces the overall weight of the vehicle dramatically, which in turn means you need less energy to propel it. They've estimated that electric cars could have up to 70% greater range with this technology.
Whoa, 70%.
Yeah.
Okay, now that's a number that really drives the point home. It sounds like we're talking about a potential game changer for electric vehicles.
Absolutely, and it's not just limited to cars. The article mentioned that Chalmers is also working on embedding batteries into cement. Imagine buildings that could store energy within their very walls. Now think about what that could mean for renewable energy.
Okay, now we're getting into territory that's particularly exciting for our Solar Age listeners. One of the biggest challenges with solar and wind power is storage, right? The sun doesn't always shine, the wind doesn't always blow. So having efficient ways to store energy when it's abundant is crucial.
That's exactly right. And that's where structural batteries could be truly transformative, especially at the scale of buildings. Imagine a future where skyscrapers and entire city blocks could act as giant energy storage systems, soaking up excess solar power during the day and releasing it as needed. This could make renewable energy sources far more reliable and practical on a large scale.
Yeah, it's a really fascinating concept, isn't it? We're so used to thinking of batteries as these separate, bulky things, but what if they were seamlessly integrated into the structures all around us?
You would be a total game changer, especially, for the transition to a cleaner energy future. Thinking about buildings as giant batteries, that really resonates with the Solarpunk idea of integrating sustainable technology into our everyday lives. It's like something straight out of a utopian sci-fi novel.
Right.
Yeah, it's an inspiring vision. And it's becoming increasingly plausible as these technologies advance. But let's bring it back down to earth for a moment. While the potential benefits are huge, there are also some challenges to consider.
That makes sense. I imagine like scaling up production is going to be a hurdle. Are we talking about like totally different manufacturing processes compared to traditional batteries?
Yes and no. Some of the basic principles of battery manufacturing still apply, but there are definitely new challenges to address. For example, ensuring the carbon fiber electrodes are evenly coated with the electrolyte material, and maintaining structural integrity throughout the production process are key considerations.
So it's not just about making a good battery. It's about making a good battery that's also a load-bearing structural component. That adds a whole other layer of complexity.
Precisely. And then there are the economic factors to consider. Right now, structural batteries are more expensive to produce than conventional batteries. But as with any new technology, we can expect those costs to come down as production scales up and the manufacturing processes become more efficient.
Right, as you mentioned earlier, the weight savings and increased efficiency could offset those initial costs,
Yeah.
especially for applications like electric vehicles. But okay, let's talk about a specific example that I know is relevant to you as a Solar Age podcast listener. Imagine these structural batteries being used in homes powered by solar panels. Can you kind of walk me through how that could work?
Sure. So let's picture a typical house with a rooftop solar array. During the day, the solar panels generate electricity. Some of that electricity is used to power the house, but the excess energy can be stored in the structural batteries embedded in the walls or even the foundation of the house. Then in the evening or on cloudy days, when the solar panels aren't producing as much power, the house can draw on the energy stored in those structural batteries.
So it's like having a built-in backup power system that's charged by the sun. That would address the intermittency issue of solar power head-on. And if you could scale that up to entire neighborhoods or even cities, we're talking about a completely different energy landscape.
Absolutely. And imagine the possibilities if you could combine this technology with other innovations in smart grids and energy management systems. We could create truly resilient and sustainable communities, powered by renewable energy and capable of managing their own energy needs locally.
Okay, I have to admit this is getting me pretty excited about the future. But let's be realistic. When might we actually see this technology in our homes and cars? Is this something that's just around the corner? Or are we talking about decades down the line?
That's the million-dollar question. And as with any emerging technology, it's difficult to give a precise timeline. However, based on the progress being made by companies like Chalmers spin-off Synonis AB, it seems likely that smaller-scale applications like thin phones and laptops could hit the market within the next few years.
Okay, so maybe not quite tomorrow, but sooner than I might have expected. But what about those more ambitious applications, like electric cars and buildings with integrated structural batteries?
Those will likely take a bit longer, perhaps a decade or more, to become commercially viable on a large scale. These applications require even greater energy storage capacity, durability, and safety standards. It's a complex engineering challenge, but the research and development are progressing rapidly.
It's reassuring to know that brilliant minds are working on this,
Yeah.
and I'm definitely going to be keeping an eye on the progress. But you mentioned safety, and that brings up another question. If the battery is literally part of the structure, what happens if it gets damaged? Is there a risk of fire or other hazards?
That's a valid concern, and researchers are working diligently to address those safety issues. One approach is to use solid-state electrolytes instead of the liquid electrolytes found in conventional batteries. Solid-state electrolytes are less flammable and more stable, which would make structural batteries inherently safer.
That makes sense, and it sounds like they're really thinking about these things from all angles, not just focusing on the performance side of the equation.
Absolutely. Safety, durability, and cost-effectiveness are all crucial factors that need to be considered in order for structural batteries to achieve widespread adoption.
This has been incredibly insightful, and I think it's fair to say that structural batteries have the potential to revolutionize not just the tech industry, but also the way we think about energy storage and sustainability.
I couldn't agree more. It's a technology with far-reaching implications, and it's exciting to see how it continues to evolve.
And for you as a dedicated Solar Age podcast listener, I think this is a development to watch closely. It could be the key to unlocking a future powered by clean, abundant, renewable energy.
Absolutely. And for anyone passionate about a sustainable future, structural batteries offer a glimpse into a world where energy storage is no longer a limitation, but an integral part of our built environment.
Yeah, it really does feel like we're on the verge of something truly revolutionary. But even with all this talk about electric cars and buildings that double as batteries, I think it's important to remember that these innovations are ultimately about people. They're about creating a better future for all of us.
That's a crucial point. Technology is a tool, and it's up to us to use it wisely, to address the challenges we face. like climate change and the transition to a cleaner energy system.
And that's what's so inspiring about structural batteries. They're not just about making cool gadgets. They're about fundamentally changing the way we think about energy infrastructure and even the relationship between humans and the built environment.
Exactly. Imagine a world where the very structures we inhabit are actively contributing to a more sustainable and resilient future, where buildings are no longer passive consumers of energy, but active participants in a dynamic and interconnected energy ecosystem.
It's a powerful vision.
Yeah.
And it's one that I think resonates deeply with anyone who's passionate about the transition to a renewable energy future.
And for you as a dedicated listener of the Solar Age podcast, I think this technology has particular significance. It could be the missing piece of the puzzle, the key to unlocking the full potential of solar and wind power.
I think you're absolutely right. Structural batteries could be the game changer that finally allows us to move away from fossil fuels and embrace a truly sustainable energy future.
And that future might be closer than we think. As research and development continue to accelerate, we can expect to see structural batteries integrated into more and more applications in the coming years.
It's an exciting time to be alive, to witness this incredible wave of innovation, and to be part of the solution.
I couldn't agree more. And as we wrap up this deep dive, I want to leave you with one final thought to ponder. If the very buildings we live and work in could store energy, how would that change our relationship with power, with the environment, with each other?
That's a profound question, and it's one that I think we'll be grappling with as this technology continues to evolve.
It's a question worth pondering, and it's a future worth striving for. A future where energy is clean, abundant, and seamlessly integrated into the fabric of our lives.
That's a perfect note to end on. Thanks for taking this deep dive with us and for sharing your incredible insights.
It's been my pleasure.
And to all our listeners, thanks for joining us on this journey of discovery. We hope you learned something new and that you're as excited about the future of structural batteries as we are. Until next time, keep exploring, keep learning, and keep asking those big, mind-blowing questions.
If you enjoyed this episode of The Solar Age, don't forget to like, subscribe, and hit the bell button so you won't miss any future episodes. We'd love to hear your thoughts. Drop a comment below about what resonated with you or share any ideas you'd like us to explore in upcoming episodes. Let's keep the conversation about a brighter future going.